Welcome to Analytik Jena's video tutorial series on combustion elemental analysis of edible oils and fats. You're watching the 4th episode about calibration and measurement. Make sure to check out the other episodes as well on our Analytik Jena YouTube channel.
In the food, oil and gas and petrochemical industry, compliance with product specs and analytical regulations is crucial. This means sample supply, analysis process, calibration and sample pretreatment have to meet these requirements. Colorimetric titration is an absolute method according Faraday's law. That means a calibration should not play a role. This is true for high contents up to 100 mg per liter, but in purity control, traces play an important role. Here a calibration is a clear advantage. Its validity must be checked every operation day by a measurement of at least one certified standard. When calibrating an analyzer for the trace range, it is important that the analyzer is clean before starting. This can be ensured by injecting several times the ultra-pure solvent. The system is proved as clean when the results are stable and close to the desired limit of detection. Calibrations are normally done with variable concentrations and constant volumes. We need at least 4 different concentrations, 3 replicate injections per each standard. The gained values are processed by linear regression as required by the analytical standards. A good calibration is linear with a correlation coefficient of at least 0.999 and a limit of detection lower than the desired lowest quantity. Once the system is warmed up, the tightness has to be checked before the first analysis. This can be done manually with an external flow meter, or if the system has an integrated flow sensor, conveniently automatically. In routine operation, a daily workflow should be well established. Firstly, you should ensure the cleanliness of the analyzer by running an ultra-pure solvent as a blank. As a next step, you have to confirm the performance and the calibration. To do this, you have to measure a certified standard. When using a solvent-based standard, it is important to take the solvent blank into account to prevent too high analytical results. If the deviation is in the allowed range, that means less than 20%, the analyzer is ready for the sample analysis. Samples without dilution are measured directly. For diluted samples, the dilution ratio and the density of the solvent will be set in the software. This is a typical daily routine in analysis of chlorine in palm oil. The sequence entries are processed now automatically. The results are available when the measurement is finished. Highly viscous liquids can be dosed like solids. Therefore, they are weighed into sample boats. It is important to add also a quartz material to prevent a too vigorous reaction and a too fast evaporation process. Sample supply can happen manually or fully automatically. The aqueous phase of the extraction can be analyzed directly by injection into the colorimeter cell. This is possible since the chlorine is already in the ionic state. Combustion is not necessary. That saves valuable analysis time. An additional advantage is that water-soluble organic chlorine compounds are not measured. The precise knowledge of organic and inorganic chlorine is a valuable tool in risk prevention for the process and the final product. After the analysis is finished, the results will be evaluated before releasing them to the customer and authorities. Now I'm finished with our short best practice for oil analysis. I hope you were able to gain some insights and information which enables you to make your oil analysis even more efficient.